Hello and welcome everyone. Thank you for joining us for another session of the Earth Engine User Meetup. We are really excited to have Dr. Emma Izquierdo-Verdiguier today, who will be our speaker. So we'll give everyone a few more minutes to log in, and we'll be hearing from her soon on her talk on analyzing the impact of climate change on spring onset, new continental scale data for its understanding. So a little bit about our speaker today. Emma is from BOKU, which is the University of Natural Resources and Life Sciences in Vienna, Austria. And there she is a senior researcher. Emma is also a Google developer expert for Earth Engine. So you can feel free to look Emma up on social media and follow her on Twitter or LinkedIn. So I will tell you also a bit more about the Earth Engine user meetups. We are a user meetup which is run for users by users. Each month we feature community members who use Google Earth Engine who want to share about their work and research. And our meetups are free and open for anyone to join. So regardless if you are an advanced user or you're completely new and are curious about how you can use Earth Engine, you're welcome to join us. And we have YouTube recordings. So some people aren't able to join live because of time zone differences. You can always follow the meetup recordings afterwards on our YouTube channel at Earth Engine User Meetup. And to get more information about the next set of events, please feel free to subscribe to our mailing list, which is tied to the ThriveGeo mailing list as well. So our next meetups are happening in June. Join us with Dr. Samapriya Roy from Naxar. Sam's also the creator of the community catalog, where there are over 375 terabytes of data stored. And feel free to learn more in his talk in June. And then we'll be on a summer break for July and August. So enjoy your summer. But join us again back in the fall because we'll be restarting this event series going with a cloud-native geospatial theme. We are launching a limited speaker series where we will bring together some speakers who will help us situate Google Earth Engine in the wider cloud-native geospatial landscape. So Earth Engine is a pioneer in cloud-native geospatial. It's the first time where so many of us got access to huge amounts of data and the computational power in the cloud in Earth Engine. So we are looking forward to also learn a bit more about what does cloud native mean? What are some of the technologies that are behind the scenes in Earth Engine? How does it connect to Google Cloud, for example, the Google Cloud Platform? And then we'll also be looking at other developments in the landscape. So we'll be sharing more information in June. And yeah, if you have any ideas for what you'd like to hear about or learn about, feel free to get in touch and let us know. All right. So without further ado, I'd like to welcome our speaker back on stage, Dr. Emma Izquierdo-Verdiguier, and she'll be sharing again today on analyzing the impact of climate change on spring onset, new continental scale data for its understanding. So over to you, Emma. Thank you.
Thank you, Sabrina. I'm going to share my screen. Oops. I think you can see my screen now.
Yes, it looks great.
Thank you. Thank you for the nice introduction and also for inviting me to do this presentation today here. As Sabrina said, I'm going to talk about how we can analyze the impact of climate change on spring onset. And in order to do that, we developed a new continental scale data in order to try to make sense and understand all the process. As also Sabrina said, I'm Emma Izquierdo-Verdiguier. I'm working in the Institute of Geomatics in the University of Natural Resource and Life Science, BOKU, Vienna. And I did this work in collaboration with Raúl Zuritamilla from the ITC faculty of the University of Twente, and under the umbrella of the 4TU research data, which was a project in order to create a database fair, which is a findable, accessible, interoperable, and reusable data set. In order to create this data set, first of all, we need to know that it is really important knowing the impacts of the spring in the databases, in the community, in the ecosystems. It is really important to know that when the spring changes over the time, because I need to say that spring doesn't start every 21st of March as the news and the newspapers publish every year. This is variable over the time. That affected to different type of communities, ecosystems, humans, and different type of fields. One of them can be the birds. The birds start to migrate from the north to the south at the moment that the spring arrives, at the moment that the spring comes. Also, many birds time their nesting so that the eggs hatch when the insects are available to feed the nestlings. And the insects appear when the plants start to leaf, to grow the leaves in the area. Another field which is really important to know when the spring starts or when the spring is coming is for humans. At some point, there are a lot of allergic people that are very sensitive and has secondary effects about the pollen in the atmosphere. And then it is really important for them to discover and know when the spring is coming in order to start to take the pills or the medicaments to avoid these secondary effects of the spring. But last and not least, there are also a community of the farmers and gardeners that they need to know when the spring is coming, because as I commented before, is the moment that the insects start to grow up. So it's the moment that the farmers and gardeners need to know when the spring comes in order to fertilize and in order to use pesticides to avoid the insects problems and disease in the crops or in the gardens. Also, they need to know when it is required to plant the crops in order to avoid some frozen days. And then in that case, they are going to avoid which is called the false springs, which is the moment that appear one frozen day before the plants start to grow up, and then that frozen can kill the plants or can kill the crops. For all these reasons, it's really, really important to monitor the phenology events in order to know what is happening and how is evolving that changes, and then use that information to provide to the different fields that require to know when the spring is coming. For these reasons, the US Global Change Research Program considers the start of the spring as one of the climate change indicators. As you can see in this slide, the cherry trees in Washington, D.C. area every year start to blooming in advance than the previous one, especially in the last years. For these reasons are needed to have some indicators, because it is related the high temperatures that we had in the last years with the early bloom and early leaf of the plants in the earth. In order to recognize or to be recognized as a climate change indicators, the US Global Change Research Program considered them as a measures or observations that can be used to track and monitor climate-related conditions, trends, and impacts. These observations or measures must be physical, ecological, health, or societal. And they are used to evaluate the risks and vulnerabilities and help inform resiliency and adaptation planning in a changing climate. You need to consider that there is only 18 indicators recognized by the program. And as I commented before, one of them is the start of the spring. And the start of the spring is defined as the day when the plants accumulate enough heat and then start to initiate the growth, that is the living, as you can see. You can see here. I can also use this one. The leaf out, or when happen the bloom in some specific temperature-sensitive plants. So, for this reason, in 2013, Marcus Bark developed the Extended Spring Index models, which are a set of simple models based on growth degree hours. This growth degree hours is measured with the inputs of the maximum and minimum daily temperatures that the model requires, in addition with the day length, that is, the hours that we have sunlight in a specific point of the Earth. These models provide three different three different phenology products. The leaf, when the plants start to grow the leaves. The bloom, when the plants start to flowering or blooming. And the damage index, which I commented before, provide information when the leaf happened and few time later appear a frozen day. In that case, we can say that it is the false spring. So the damage index provides information when it is happening the false spring. And you need to consider that, as I commented before, the start of the spring is only calculating using temperature-sensitive plants. In that case, the extended spring index models using three different types of plants. Syringa vulgaris, lilacs, which we have observations in America and the European continent. Lonicera tartarica, Arnold red honeysuckle, which we have observations in the America region, and the Lonicera colorcovic sabelli, which also we have observations in the American region. The spring index models at the beginning in the most previous studies were based on plants and weather observation stations, as you can see in the figure, and were calculated using different type of programming language. The original model was developed in Fortran, and after that, a MATLAB toolbox was developed in order to produce the punctual or specific locations of the phenological events. However, after that, some works developed some grids, specifically grids, to provide spatial information. And in that case, the spatial resolution of the grids are coarse spatial resolution. In that case, there were different type of products from 25 kilometers to 4 kilometers spatial resolution. However, thanks to the new technologies, and specifically in this case and in this work, the Google Earth Engine, we could develop a new database which provides the leaf, bloom, and damage indices at 1 kilometer spatial resolution. This dataset provides different temporal series of the products over the European continent and in America region. You need to consider that depending on the input data, that is the daily maximum and minimum temperature available, the European temporal series was developed in 71 years, from 1950 to 2020, and was used the EOPS downscaled provided by BOKU. In the case of America, the temporal series covers 71 years and was developed using DAIMET from 1918 to 2022. We are waiting that the DAIMET is ingested of the year 2023 in order to provide the last year. Here you can see the animation of the leaf index for the from 1980 to 2015. That was the animation provided at the moment that we published the paper in the Agriculture and Forest Methodology, only for the contiguous United States. In that case, you can see that in most of the cases, the early spring happened at the south of the continuous United States. These are the results that we obtained in the European continent. And in this case, you can note it that in most of the case, in the south part of the continent is when the spring happened in advance, happened before. But also we can see that in some specific years in the area of France and also can acquire in some areas in England that the spring happened very earlier over the years. Also, we calculate different type of statistics from our temporal series. You can see the results here in the American region, where we calculate the average of the temporal series and the trends of the temporal series. Two things that I would like to highlight is, in the case of the American region, is clearly noted that the spring happened earlier than in the north part of the country or in the mountain regions. In the case of the European area, as we noted before in the animation, the leaf index happened earlier, not only in the south, also in some coast areas of the country. But one thing that I would like to highlight more is the tendency of the leaf index over the different years. Here you can see the tendency in the American region, where in the south area happened earlier the leaf index, and in the case is happening earlier, is the spring come in advance. Meanwhile, in the north part of the area, the spring appears, is delaying over the time. Meanwhile, in the case of European continent, which is in northern altitudes than the American region, all the continent the spring happens in advance over the time. And that is reflects with the highest temperatures that we had in the previous years over the Europe. I don't know if you remember that last summer in Europe, we catch the maximum temperatures over the time. Here you can see the behavior of the bloom index. You need to consider that the bloom index is calculating using the day of the year of the leaf index. So the behavior of the bloom index is practically equal than the behavior of the leaf index. The only difference is that the bloom index happen in later days of the year than the leaf index, but the rest of the things are quite similar than the previous one. And in this slide, I show you the results that we obtained with the damage index. In this case, we can note that there are very few spots in Europe that or there is a probability to have a false spring in the area. In the case of America, that probability happened more in the south part of Canada and in some areas of the US. And you can note it that in the tendency of the damage index, the damage index is happening in advance only at the south part of the American region. In the case of Europe, the trend of the damage index is very randomly, and we cannot provide, except of the east part of the continent, we cannot provide any pattern, spatial pattern of them. We validate our products, of course, using different type of observations. In the case of the American region, we validate using the National Phenology observations provided by the NPN. And in the case of Europe, we validate our results using the Pan-European Phenology Database, PEP 725, provided by different countries in Europe. In that case, you can note that the results are quite good. Any of them are higher than 18 days. And in the case of the worst results are in the LEAF index for the European region. In order to analyze what happened in that index in the European region, I plotted the temporal evolution of one specific observation in Croatia. The latitude in Croatia is at the south of the continent. That is supposed that the observation should be more or less at the beginning of the year, more or less. I mean, not higher than 100. And we can see in this figure, the green dots are the phenology observations acquired by the voluntaries. The blue line is the predictions that were provided by the spring index, extended spring index models. And the gray line are the bloom predictions of the models. In this case, we can note that in most of the cases, the observations are closer to the bloom than the leaf index predictions. Another example that I provide is in a station or in an observation in the area of Germany, in the German country. We can note that in this case, this observation was reported as a bloom observation. So the green points that you can see in the figure are the observations that we have available for that extension over the time. In blue now is plotted the bloom predictions of the models, and in gray, the leaf predictions of the models. In this case, we can note that the predictions are pretty close to the observations, except for one specific year that the observation was reported before than 40 days of the day of the year. In that case, we need to consider that the observations, in that case, something happened with them, and we need to take care with that type of observations. In order to finish this talk about the new dataset, new phenological dataset, I show you the temporal variability of the spring index models. In this case, we split the continuous United States in 9 different climate regions. The climate regions are officially defined. And then we calculate the average per region and plot the temporal variability of the leaf index. We can see in the figure that we have three main groups of the spring. The early spring, which are totally focused in the southeast of the country, in these 2 regions, the 6 and 7 region. We have another clear group, which is the middle term spring, which are in the west part of the country and also the region number 4. And the late spring, which is covering by all the north climate regions in the contiguous United States. Also, we can note it in this figure that in most of the regions, the leaf index is happening earlier in most of the climate regions. But I would like to highlight that in the regions focused in the west part of the country, region 1 and region 9, this early spring start to happen before than in the other regions. So at some point, thanks to the new technologies, we have the opportunity to develop different type of new products. In this case, it's a new phenology data set at 1 kilometer spatial resolution, which provides us a lot of spatial and temporal information. Additionally, this data set at a high spatial resolution permits us to perform regional and local studies, analyze how the climate change affects to the ecosystem, and also permit us to synergy with additional data set, as can be, for instance, the dynamic walk land cover data set, or another type of remote sensing products or satellite products. So thank you very much for your attention. And if you have any question, I will be happy to answer them.
Thank you so much, Emma. This was a great talk, and it was certainly very interesting to see how rapidly these changes are happening also in both the United States and in Europe. So let me switch over back to sharing our tab here. So now it's time for question and answer. And I'd like to invite everyone in the audience to, if you have a phone, take your phone and scan this QR code. Or if you're at your desktop, you can go to slido.com and type in the event code #EEUM. And this will take you to our event page where we will be using to do the question and answers. So I am going to open the first question to the audience as we wait for people to join us. So could you tell us where are you joining us from? Scan the QR code or go to the website and type in your answer. I will also do the same here. Okay, so I see 3 participants are typing. All right, we have Istanbul, Italy, Germany. Okay, I'll get people a few more seconds to join us in Slido. Okay, if not, I have another question for you, which is, what was your main takeaway from the talk today? So after listening to Emma's talk, okay, we have also people joining from US and India. Awesome. So what did you learn from the talk today? Feel free to take a few minutes and share your thoughts.
Sometimes it's not easy answer at the same time.
No, it's okay. Okay. So data availability is a big takeaway. For me, it was the interesting observation you had that the western part of the US and also the western part of Europe was experiencing the spring onset earlier and also going down rapidly in terms of the days in the southern parts. What data is used? Yeah, definitely. And we can do a lot thanks to new technologies like Earth Engine to address climate impacts. Yeah, these are great takeaways. Thanks for sharing them. So now I'm going to give you, the audience, a chance to ask Emma some questions. So once again, feel free to type your question on your phone or on your laptop, and it will be posted onto Slido, and then we will answer the questions together. Okay, so as we wait, Emma, could you share a little bit about your welcome to the person from Ivory Coast as well? Could you share with us a little bit about some, maybe in the process of creating this data set, what were some of the challenges you faced and how did you overcome them? You can pick like 1 or 2 that you found particularly important.
Yeah. Well, I can say that first challenge that I found when I developed the data set was learning Google Earth Engine, because I started to learn Google Earth Engine when I started to develop this data set. It was a long time ago, I know. And in that case, to me, was a huge challenge, a big challenge in the way that not only adapted the model from local to cloud computing, also because it was a period of time when Google Earth Engine didn't have too much documentation. At some point, I needed to learn by myself. Another thing that I found complicated was manage, well, it's related with working with Google Earth Engine at some point, but was how to create the different long and short accumulation of the temperature that the model inside internally has. And then I needed to rewrite several times the code in order to have a running code that was correct and also provide good results. And at the end, another important thing and a difficulty that I found in that period of time was in the part of the validation. You need to consider that the observations of the phenology events before were done by experts, but arrive at some point that rules change, and then voluntary people provide phenology observation. So at the end is social science, and then in that case is complicate validate a database with a voluntary observations because require a lot of cleaning in the databases.
That's certainly fascinating that you covered both technical challenges from the documentation, the lack of documentation, and learning Earth Engine, implementing the model on cloud computing, on a cloud computing platform, and then also working with the social science aspects of volunteer provided data. So it really sounds like this data set took a lot of time and effort to create, and thank you so much for sharing about it with us. We have two questions here about whether the code that you use to generate this data set is, you mentioned it's fair data set. Do you also have the code available from the publication?
Yes. We have the publication nowadays under review, so we are waiting until the publication is officially published. And in that case, not only the database, also the code is going to be available in order to produce your own sprint dataset events by yourselves, of course. But we are waiting the red line of the publication. This is a scientific work in progress, so we are waiting the green line of the publication. And in that case, yes, it's going to be GitHub with the code repository, will be an application on Google Earth Engine that people could visualize the data, also if they don't have a user account of Google Earth Engine, and will be the dataset repository by itself. And also the idea is try to publish the dataset in the EWOS-ON dataset that probably Sam Apriya is going to talk about in his next talk.
That's great. I'm glad to hear that the publication is underway, and then people can get access to the code and the data soon. So yeah. Are there any more questions from the audience to Emma about the data or the process? I imagine there might be some people in the audience who are also working on similar research, but in your own country. So feel free to drop any questions in the Q&A. So Emma, it's quite fascinating because you mentioned that after a while the rules changed, and now citizen scientists or voluntary data for the phenology is now accepted.
Mm-hmm.
But before you said it was all experts, right? So
Yeah.
do you see a change at that point where, you know, the rules change and then more citizen scientists came in, and how do you, like you mentioned, you did a lot of cleaning. I wonder if there are still experts who are sharing this data. Are they tagged like expert so that the data point, you know, is from an expert versus a citizen scientist, or it's all mixed up?
Of course, there are differences, first of all, in the quantity of the data that the agencies acquire at some point, because it's not the same to have some specific experts in order to go to the field and then controlling the plants to report when it starts to leaf or bloom. Also was related, of course, with the quality of the data, because as I commented before, when you have experts, they are more, I don't want to say motivate, because at the end also the voluntaries are really, really motivated. But maybe one day they jump to go to the place to observe a specific plant, and then it's the day that the plant bloom or leaf, and then the report of the day of the year that the leaf or bloom happen is 1 day, 2 days, X days later than when in real happened, and that is in the detriment of the quality of the data set. But for sure, the higher change is the quantity of voluntary observations that the agencies can acquire is higher, of course, compared with the other one. And this is also nice and good for us. Also, we need to consider that it's needed to clean more hard work cleaning at some point the databases. But provide much more information that we had before in advance than experts went to the field.
Absolutely. I can imagine it's probably not every day that you have someone who will go every day to the same plant to check if it's already blooming or not, and then sending that notification or recording that. So yeah, there probably are some people like this, but not many people who will be dedicated like that.
There are people, I know that there are people, also I know that there are people that not only report the day, also I know people that make a continue monitoring of a specific lilac plants at some point, and they have 4 years, 5 years of or more photographies of the lilac plant in order to see how the plant grow up and leaf and bloom every year. So I can say that there are really motivated voluntaries, but also there are voluntaries that only report the event when they pass by the plant, and they don't do that maybe every day. So yeah.
Absolutely. So I again welcome people to post any questions for Emma here. So in addition to the challenges you mentioned, Emma, while you were working on Earth Engine, could you tell us a bit more about maybe some tips or tricks that you found when you were trying to implement the model maybe in Earth Engine? Like what are some tips you would share with other people to do something similar to what you did?
I can say that, of course, use the forum. In the forum, there are a lot of help and a lot of information. I discovered that I started to work in Google Earth Engine, and to me was really helpful. Not only because the Googlers answer a lot of questions and they are really helpful, and from here I would like to thank all of them, all the help that they provide, not only in this work. I develop different type of works on Google Earth Engine, and every time that I have a problem or I have a question, they help a lot. And also the other users. At some point, we are a huge community of users with a lot of knowledge, not only by the GDEs, also different users has a huge quantity of knowledge, and they help a lot in the forum. So one of the main tips is, well, first of all, try to read the questions that are already in the forum, because that forum is working at least from 2014, 2013. So it's long over the time, and there are a lot of information there. And I didn't experimented that from my beginning period of time, but time to time nowadays I watch different videos of Google Earth Engine, how to do different things in YouTube. So I can say that I'm super surprised. Maybe I'm old nowadays with that, because to me, surprised a lot the quantity of information that you can find on internet, in YouTube, in the forums, also in the different conferences. At some point, you can find people that work with Google Earth Engine, and you can talk a little bit what are you doing in that moment, and they can give you some tips about how to improve the codes and how to do the things. And for sure, try to read the documentation that there are nowadays, because it's really good, improve a lot from the beginning. And there are different information. For instance, people that is working with Python nowadays has kind of a short translation, because there is only one short table, but at some point you can see the differences between working in JavaScript and Python. There are a lot of web pages that I know Noel repeated several times in the forum. Things that is not recommendable or not allowed to do in Google Earth Engine. Try to follow all that type of documentation, because I think that it's possible to improve a lot the way that you code using the application, reading and watching videos, of course, and later try to talk with the people that you know that are working with Google Earth Engine, because it's a huge community, and it's a very helpful community. So it's really good.
Absolutely, I echo everything that you said. Also on YouTube, if people look for past Earth Engine user summits or Geo4Good summits, there are also videos of workshops that people have done at these events, and a lot of them are also focused on Earth Engine. So you can get access to tutorials, videos, and try and follow along on your own. And yeah, definitely, like Emma said, the Google Developer Forum is a great source of other community members, and a great source of information that you can search for questions and look at how they were answered. There's also Stack Exchange, Stack Overflow. I think a lot of people are also posting questions and code there. So you can also make use of those forums. All right, so last call for any questions. Please feel free to share any questions here. If not, Emma, how can people get in touch with you if they have questions afterwards?
Yeah, maybe they are a little bit shy or something. Can contact with me.
Can they send you a message or something like that? How should they get in touch with you?
They can contact me by LinkedIn. I have an active account. I have also X or Twitter account, which I need a little bit more time for check it, I can say. Not for other reason, is because I don't have all the enough time that I would like to check all my accounts. But in that case, time to time I check Twitter, but for sure in LinkedIn it's possible to contact me. And yeah, also I have my institutional webpage in BOKU, and they can find different ways to contact me in the webpage. So yeah, they are welcome to ask questions outline and outside of this talk.
Wonderful. And we look forward to hearing when your paper is published, and we will also share that with the community on the YouTube with a link to the paper and the GitHub once it is live. So thank you once again to everyone for joining us today. And I look forward to seeing you all in June, on June 14th, for the next talk by Samapriya Roy. So thanks again, and I wish you a good rest of the day. Thank you, Emma, for this great talk. Goodbye, everyone.
Bye.
Bye.